Claude Opus 5 costs exactly half what Claude Mythos does, $5 in, 25 out, versus 10 and 50 per million tokens. At real scale, that gap adds up fast. Both models are live right now, and the stakes are real. I'm comparing Claude Mythos versus Claude Opus 5 across 5 tests to find out who actually wins. The twist is that one of these models you literally cannot get right now, and that access gap changes everything about the cost math. My name is Brian, and I'm in these tools 12 hours a day, so you don't have to be. Every number in this video is traced back to official model cards and vendor announcements. If you're running agentic workflows at a few million tokens a day, picking the wrong model here costs you real money every single month. Test 1 is cost, and the number itself is the opener. Claude Mythos is priced at $10 input and $50 output per million tokens. Claude Opus 5 is 5 and 25. That's the same ratio across every pricing tier, including cached inputs. So run 10 million tokens a month, and that gap is hundreds of dollars before you've shipped a single feature. What I looked at here was the full pricing table across standard API, cached input, and batch. Claude Opus 5 is exactly 2 times cheaper on both input and output tokens. Cached input is $1 for Mythos, 50 cents for Opus 5. Batch API for Opus 5 is $2.50 and $12.50 per million tokens. I couldn't track down a batch figure for Mythos at all, which matters if you're running large, offline jobs. Claude Opus 5 takes cost, and it's not close. The ratio is identical across every tier, 2 times cheaper, full stop. Mythos doesn't even have a batch figure on record, so if you're doing offline processing at scale, you're flying blind on one side. That puts Claude Opus 5 on the board first, Mythos still at 0. Test 2 is coding benchmark performance, and the number that leads this one is 93.9%. That's Claude Mythos on SWE Bench verified, which is the closest thing we have to a real-world coding stress test. The objection I keep seeing is that Opus 5 hasn't published a SWE bench number, so how do you actually compare them? That's exactly what I dug into. What surprised me is that these two models were never measured on the same benchmark. Mythos posts 93.9 on SWE Bench verified and 82 on Terminal Bench 2.0. Opus 5 scores 8.2, 7 out of 10 on Goldie Bench and leads head-to-heads against GPT 5.6, 25 to 18, and Fable 5, 29 to 12. Different ladders, different tests. I won't force a comparison that isn't there. Coding benchmark performance is a dead heat, and that's the honest call. Mythos's 93.9 is a striking number, but Opus 5 was never even on the same test, so there's no clean winner. Calling it for either side would be making up data. Score stays at Opus 5 1, Mythos 0, with one test tied. Test 3 is speed, and the number that matters here is 2.5. That's the multiplier on Opus 5's fast mode, which is a documented feature. The real question is whether Mythos has anything comparable, because if you're running a long agentic loop with dozens of tool calls, waiting on a slow model compounds fast and kills your iteration time before you even get to debugging. The speed data is pretty thin on both sides. Opus 5 has a documented fast mode at 2.5 times default speed, and that's a real feature you can actually flip on. Mythos's runtime speed is explicitly marked as not measured on Bench LM, and I couldn't turn up a tokens per second figure anywhere. So you're comparing a documented feature against a blank space. Speed is another tie, and I want to be straight about why. Awarding a win because the other side has no data isn't a fair call. No data isn't the same as slower. Speed stays undecided. That's Opus 5 at 1, Mythos at 0, with 2 tests now tied. Alright, so we've got context and output limits and deployment still to go. And deployment is the one that could completely change how you think about the cost gap we looked at earlier. Because if you can't actually get access to the model, the price doesn't matter at all, right? That context test is coming up right now, and it's more interesting than you'd think. Test 4 is context and output limits, and the number that leads here is 1 million tokens. Both models land on a 1 million token context window, which is the headline spec for any serious agentic workflow. The output side is where things split, because if you're generating long-form code or reports, a capped output limit cuts your run short and forces you to stitch responses together manually. Both models sit at 1 million tokens on the input side, so that's a clean draw. Opus 5 has a published 128,000 token max output, which is a documented spec. For Mythos, I couldn't locate a published output limit anywhere. There's a community-reported 4 million token-tiered attention figure floating around, but that's single-sourced, and I'm treating it as unverified. Now, the 4 million token figure for Mythos is interesting, and I get why people are excited about it. But a single community report isn't something I'll build a verdict on. The honest read is that both models are spec'd at 1 million on context. Opus 5 has a clear output number, and Mythos doesn't. That gap might look bigger than it is if Mythos' output limit turns out to be comparable once Anthropic publishes it. Context and output limits is a tie. Opus 5's published 128,000 output spec is a real number, but the context window match at 1 million tokens keeps this even. Mythos' output limit is just undisclosed, not proven worse, so no winner here. Running score stays at Opus 5 1, Mythos 0, 3 tests tied. Test 5 is deployment and modality, and this is the most practically important test in the whole comparison. The day you pick a model for your production stack and then find out you can't actually get an API key, your whole timeline slips. Claude Mythos is gated behind an invitation-only program called Project Glasswing, and that single fact shapes everything else we've talked about. What I looked at here is availability, platform support, and enterprise controls. Claude Opus 5 is generally available right now on the Claude API, Claude.ai, Bedrock, Google Cloud, and Foundry. Claude Mythos is on those same platforms, but only if you have an invitation through Project Glasswing. Opus 5 also has a documented 0 data retention option for enterprise, and I couldn't turn up a comparable figure for Mythos on that front. Claude Opus 5 takes deployment, and this one isn't a close call. The platform list is roughly even, but the gated access on Mythos is a hard wall. You can't ship with a model you can't get. That's Opus 5 picking up its second win, Mythos still at 0, 3 tests tied. Okay, so here's where Claude Mythos genuinely pulls ahead. It posts 93.9% on SWE Bench Verified and 97.6 on USAMO 2026, and it's ranked number 1 of 214 models on Bench LM, with coding ranked number 1 of 129. It also autonomously completed a simulated corporate network takeover in 3 of 10 attempts, which is a frontier cybersecurity capability that Opus 5 hasn't matched on paper. And here's where Claude Opus 5 wins cleanly. It costs exactly half of Mythos across every pricing tier, $5 input and $25 output per million tokens. It's publicly available right now with no invitation needed. It has a documented 0 data retention option for enterprise, and it leads Goldie Bench head-to-heads against GPT 5.6, 25-18, and Fable 5, 29-12, so you can actually use it today. So here's the honest call. Mythos' benchmark numbers are stunning, I'll give it that, but you can't use a model you can't access. If you need frontier cybersecurity capability, or the absolute top of SWE Bench at 93.9%, and you have a Project Glasswing invite, Mythos is your pick. If you need a model today at half the price, that's Claude Opus 5. 2 wins, 0 losses. If you want to see how Claude Opus 5 actually holds up against a free local alternative, I did a full head-to-head in my Olama versus Claude code video, where I ran a free local stack against a paid API to see if it can actually keep up. The results are pretty interesting, and they connect directly to the cost gap we just talked about.